First, we're gonna see the theory on Faraday's law. What is Faraday's law? Faraday's law of induction is a basic law of electromagnetism predicting how a magnetic field will interact with an electric circuit to produce an electromotive force. The electromotive force is known as electromagnetic induction, and this is the formula for the Faraday's law. As we seen in the formula, the electromotive force induced is the negative change in the magnetic flux per unit time. So Faraday's law states that any change in magnetic field or change in orientation of the area of the coil with respect to the magnetic field induce an voltage, which is known as the electromotive force. Magnetic flux is a measurement of amount of magnetic field lines that goes through a given surface area. This image is an example of the situation where magnetic flux passes through a given surface area. The magnetic flux is the amount of field lines cutting through a surface A defined by an unit area vector n. Angle between the unit area n and the magnetic field vector B are parallel or antiparallel like the diagram at the side. The magnetic flux is the highest possible value given the values of area and magnetic field.
Hello guys, my name is Vinod and I am from group 5. Today we are going to demonstrate the electromagnetic induction similar to the one that Michael Faraday performed. We have an ammeter and we have 3 coils with 1 loop, 10 loops and 100 loops. We also have a bar magnet and we'll start by connecting the single loop coil to the ammeter. We now have the single loop coil connected to the ammeter and we are going to move the bar magnet into and out of the coil. And if you watch very closely, you can see a slight deflection of the ammeter needle. So now we'll connect the 10 loop coil and we are going to do the same thing. We are going to move the bar magnet in and out of the coil. Now you can see more movement of the needle. If we go very slowly, you can just see a little bit of deflection, and if we go quickly, a greater amount of deflection. Also, as the bar magnet is going in, the needle deflects to the right, and also once the bar magnet is pulled out, it deflects to the left. And when the magnet is moving, there's no deflection, indicating there's no current flowing. When the magnetic field is changing going into the coil, there's a positive current flowing. When it's changing coming out of the coil, there's a negative current flowing. And now let's connect the 100 loop coil and we'll start by moving the magnet very slowly. We'll see a deflection to the right and left, and if we go quickly, there's a greater deflection. So the rate of change of the magnetic field deflects the current also.
My part is question related to Faraday's law. The question is shown in this slide. The figure 1 will be shown in a moment. We have 2 sub-questions, which is the magnitude of EMF and magnitude of current. These are the important points taken from the question. Okay, for theory, area vector is perpendicular to area covering the loop. We choose this to pointing towards downward so that electricity field is parallel to area vector. Since the area of the loop is not changing in time, it can be factored out of the time derivative, as the magnetic field is the only quantity varying in time. We can apply Ohm's law once we know the induced EMF to find the current in the loop. If we substitute the value, the answer will be 0.5 volt. When we substitute the value, it will be equals to 0.1 ampere.
So now we are going to talk about the application of Faraday's law in real life. And the application that we are going to discuss today is microphone, which works on the principle of electromagnetic induction to convert sound energy into electrical energy. And before we understand about the working principle, we can first look at the basic structure of a moving coil microphone, which is made up of a diaphragm, a moving coil, and a permanent magnet. So a diaphragm basically is a thin piece of metal, plastic, or aluminium that vibrates when it is struck by sound waves. And it is attached to the moving coil, and when it vibrates, it will move the moving coil back and forth around the permanent magnet. So when this happens, there will be a change of magnetic flux, which causes the current to be induced. And we can have a look on the illustration here to have a better understanding. So here is the incoming sound wave to the diaphragm, and the diaphragm will be vibrating and move the moving coil back and forth around the permanent magnet. So we can see the current is then induced, and the electrical signals that is converted will be directed to the loudspeaker or the amplifier through the wires. So when the louder the sound, the more the vibration and the movement of coils, and hence the greater the current induced. And also, when the frequency of the sound is higher, the frequency of the AC current induced will be higher as well. So it can be shown here. From here, we can see that when the frequency of the sound wave is low, the moving coil is moving at a lower speed, which then cause the EMF induced having a lower frequency as well. So when we increase the frequency of the sound waves, it can be seen that the moving coil is moving at a higher speed, and the frequency of the EMF induced is become higher. So that's all for the application. Thank you.
Hello, I'm going to explain about one real-life application of electromagnetism, which is electric guitar. Firstly, I'm going to show the parts of the electric guitar. The strings of the electric guitar are made of metal. Under the strings, they have a magnet, and those magnets are surrounded by a thin coil, and this part is called pickup. This is the pickup of an electric guitar. When the string is plucked, the strings becomes vibrate and then being magnetized by the magnetic field. The vibration changes the magnetic field around the magnet. When the magnetic field is changing, it produces an electric current. Then the electric current goes through the coil and then goes into the wire. The wire carries the electric signal wave, which created when we pluck the string of the electric guitar. Then the current goes into an amplifier, which produces larger electric current. After that, the amplified current goes to a speaker, and the speaker radiates the sound. After all, we can hear the sound produced by the electric guitar. This real-life application shows how the electromagnetic induction works. That's all. Thank you.